Hi, my name is Jacob, and I'm the inventor of the Master Reticle, the first and only working universal BDC. This is a short video tutorial that will detail how the Master Reticle works. At the end of this video, you will understand how our Master Reticle is like a BDC and yet does not meet the industry's current definition. Every existing BDC operates on a horizontal value, and I developed a vertical BDC. A lot of skepticism was met with the claim that we had developed a universal BDC and that the fact that it wasn't electronic, that it was optical. Without any ado, let's figure out how to achieve a universal BDC. And on this journey, we are going to not only outline various physics concepts, we're also gonna then take those concepts, we're gonna build a Master Reticle. We will then go on a hunt for a deer, and then we will go on a hunt for a moose. So with that, I just want to give a quick disclaimer that this video is purely exemplary. It is strictly for you as the viewer to be able to understand. It is not to be interpreted or construed in any kind of limiting manner. At the end of this, you will absolutely see how a Master Reticle works in real time. So starting with the most basic concepts, I will drop two bullets that are exactly the same weight, same size, same shape, and I will drop them from the same height and release them at the same time. Now, which bullet will hit the ground first? Well, you guessed it. Both will actually hit the ground at the same time. Why? Because gravity will have accelerated both objects at the same rate. Now, if I drop two bullets, one being slightly larger than the other, what happens? And you probably guessed it, both will hit the ground at the same time. This is true if I had a marble or a bowling ball. That's what I had discussed in my previous video. Here in that example, you have two vastly dissimilar objects. One's big, one is small, one's heavy, one's light, and yet both will hit the ground at the same time. Now, the same time, I know some people might kind of call me out on that. This same time is really a matter of frame of reference. And also, it's important to note that the bullets represent a caliber C and a weight W, so they really could be anything under that definition. So first we just dropped them. We don't know a distance. We didn't assign a distance, but now we are actually going to look at what happens when the bullets fall 5 inches, and then 10 inches, and now 20 inches. So I'm going to now assign an arbitrary Y value, a Y inch value, to designate some number as far as how that bullet might fall. Now, let's conduct the same experiment, but now from the perspective of time. And as you can see, I did not specify a time. I don't need to know if it took 1 second for the bullet to fall 10 inches. It's irrelevant. That time is relative to each other. And so in this case, I'm just looking at the time it takes for the bullet to fall 5 inches, T 5 inches, or the time it takes for the bullet to fall 10 inches, T 10 inches, 20, so forth, TY. So all we need to know is the fact that bullets will fall the same distance in Y in time T. In other words, we are evaluating strictly a vertical distance. Now, let's apply a velocity to one of our bullets. And as you can see in the first video, our bullet is moving at 2,500 foot per second, not to scale. None of these are going to be to scale. So now we will accelerate the same bullets of caliber C, of weight W, and we're gonna have it be at a velocity of 3,500 foot per second. And as you can see, and this point might be surprising to a few people, both bullets will still hit the ground at the same time. They will both cover the Y distance and hit the ground at the same time. Why? Well, this is, again, because gravity is going to accelerate both of our objects, both bullets, at the same rate. And this acceleration is independent of velocity. So in turn, the velocity could, now I gave an example of 2,500 or 3,500, but it could be a much substantially greater range. Let's evaluate this scenario in respect to time, to a time constant relative to each bullet as we did before. And to no surprise, both will still hit the ground at the same time. So now let's evaluate our bullets set at definitive Y values. Instead of having an arbitrary Y distance at the bottom, let's replace that. We're gonna assign a 40-inch value. So now our scale will show 5, 10, 20, 40 inches. Perfect. Now, I'm gonna ask for you to think of the average vital zone of a varmint, deer, a moose, and military. Feel free to add your own thought, your own example as far as what a vital or a target area, what that size might look like. But for the sake of reference for everyone, I'm going to adjust our interval to the vital zone of a deer. And for those who don't know, it is about 6 inches. We're going to use this because it's something that almost anybody should be able to relate to. Okay, so again, our distance, our time intervals are currently set to 5, 10, 20, 40 inches. Way too big for a deer. And so I'm going to change these intervals to 6 inches. There we go. Now I have 6, 12, 18, 24 inch kill zones, each spanning 6 inches, each stacked on top of the other. Let's resize our intervals to be more equidistant. All right, so now we are ready to go on our hunt. Now, since a vertical distance interval is set to 6 inches, let's evaluate our bullets. And this should look just like all of the previous examples. Now, I'm showing this to you again to emphasize that the bullets could be of any caliber C, of any weight W, and in this evaluation, you are seeing that these two bullets are falling through each interval in the same amount of time, where before we just had a random value, a random sequence of Y values. Now we have a set interval, and that concept still applies. And therefore the time constant is relative to the bullets themselves and in relation to the size of our vital. Let's, for exemplary purposes, apply stadia, red dots, at the middle of each of our intervals, at each of our vertical intervals. As you can see, I now have a reference point that describes how a bullet of caliber C and weight W will fall every 6 inches. You have just created a master reticle, an exemplary master reticle. If you are still asking how it works, let me explain. As you already know, each reference point universally describes bullets of any caliber and weight that fall every 6 inches. This means if a deer is at X distance, the bullet will not fall greater than 6 inches within its corresponding time interval or distance interval, and in turn will get a hit, and that is the act of a universal BDC. This comes without having any ballistic knowledge or understanding. It's as simple as, does it fall within a range? If so, pull the trigger. Let's say I was a hunter going out for the first time. I've never shot. I don't know how a mil reticle works. I don't know how an MOA reticle works. All I know is I got this scope, it's zeroed. I got my ammo. I'm ready to go on my hunt for this deer. And there's a QR code on the side of the scope. I would simply say, scan the QR code. It would take me to a web link or to an app that would have a handful of inputs. And two of the primary would be what's my target size, which point I would input deer, and what's my velocity. And at that point, the website or app would tell me the corresponding ranges for each dot. Now note this example does not rise to sniper accuracy, where a bullet must match point of aim to point of impact. This is about creating a near dummy proof rapid target engagement system. And this is where the range, where if our deer is within X1 to X2, that distance could span tens of yards, it could span hundreds of yards. It all depends on the velocity, and it depends on the size of our target that we input, whether it's going to be 5 inches, 20 inches, 40 inches, 100 inches. It really doesn't matter, but what does matter is the fact that when we stack those vertical zones, and depending on velocity, that will dictate what those ranges are. But the idea is that now with just 2 inputs, I get the ranges and I'm done, I'm ready to go shoot. So instead of a deer having to be at exactly 400 yards, say with a traditional BDC, the question is, does it fall within a range? And if yes, pull the trigger. Now, military, if you were to, if say you had a infantry that misjudges the distance and by a sufficient value to where they miss, at that point where they miss low, say that they use the second dot and they're supposed to use the third, they pull the shot, the second dot, and they miss just low. At that point, it's just as simple as raise the reticle to the third dot, pull the trigger, and keep repeating until you get a hit, making it super fast. Using this method, there are no gaps, there are no overlaps like a traditional BDC. It, again, is stacking a vertical value, so that way it's perfect across its evaluation. Now, keeping this PG, we'll go back to our deer, and we're going to show this in real time. We are now on that hunt, and we have already set our master reticle. We got our QR code ranges, and we estimate that the deer is at distance X, and we use our second dot, we pull the trigger, and there we see that we're low. So before the deer runs, we adjust, we raise our reticle, so the deer's vitals are now at the third dot, and we pull the trigger, hit. Now, it's important to note that in this example, I didn't know my ballistics. I didn't know my dope. I didn't know the target's precise range. I didn't know my mill. It never came up. And on that, I would ask how many people can relate to not having the experience or having mastered these disciplines. And so with the act of that QR code, outputting what ranges to use each dot, now I can memorize those ranges, or say, if you just want to be absolutely sure, I'm gonna write them down on a dope card, I'm gonna keep on my inner sleeve, but now I'm writing down a few things and not a whole host of things being, you know, again, we're looking at ranges spanning tens or even hundreds of yards, and at that point, not set intervals. And I would say that there lends a lot of advantage to this, because how often does a target stand on a 100-yard line? We just got a deer, and we are feeling good, and now we're ready to go on our hunt for a moose. And remembering from our last hunt, our master reticle is set to a deer's vital, and I need to now adjust it for a moose's vital, which is 10 inches versus the 6. Why? Because it's a bigger animal. Now, this could be accomplished using a whole host of methods described in our pending, but we're just gonna make the adjustment. And as you can see, again, we are originally set up for a deer, but now we are set for a moose. And it's important to note the position of our dots, or more importantly, their relationship to each other, did not change. Only our scale did, and this was done on the fly. I fly out somewhere, I land, I scan my QR code again to get my new ranges, and at that point, I'm well under my way to get another mount. So evaluating this relationship to where I can scale stadia reference marks unveiled a whole host of mathematical relationships, ratios. I won't expound on these, but I will simply say that with as few as 2 to 3 inputs, I can draw virtually any reticle to be ballistically matched to any caliber to act as a BDC on the fly. Finally, target size, as I mentioned earlier, can literally be any value. Our master reticle can be integrated into any MIL or MOA scope, and since we do not have to use MIL or MOA, a person could not know anything about MIL or MOA, but they could still use a master reticle. You can't say the other way. So that's where the master reticle could be integrated, incorporated into any existing scope, any existing optical method, but the same cannot be said going the other way. The master reticle acts as a medium. Now, in the beginning, I did note obvious skepticism from a lot of people as far as the claim for a master reticle that would act as a universal BDC that is optically driven. How is this possible? How can it be different? In summary, is a vertical BDC versus a horizontal BDC. And that's the big key takeaway. Where everyone else uses a horizontal value to drive their BDC, we use a vertical. So this concludes this video discussion. Please share with scope companies. We hope that you too will be able to use a universal BDC very soon. If you have any questions, feel free to comment on them below. So thank you for your time. Thank you for watching. God bless and bye-bye.